Hello, this is Mr. McGovern, and this is the fourth video in the Level 3 Physics series on the advanced DC circuits, and our second video on Kirchhoff's law where we're looking at an NCEA example. So this is taken from 2021, it's question 3D. So here's the circuit on the right here. And I said in the last video, when you see a circuit with more than one voltage supply or voltage source, you should be thinking Kirchhoff's laws. So the question, well, let's just revise the laws really quickly. There's two laws. The current law, which is the current in a junction is equal to the current out of a junction, and the second is the voltage law, which is the voltage around a loop is zero, and that has some sort of sub-rules. Make sure you follow to get that right. So we go around this loop, and if we go through a battery, and we're going through the correct way, which is the way the current goes, which is out of the positive and then into the negative, or into the negative out of the positive, that is a positive value. And if we go through a component like a resistor and we're following the current through that component, it's a negative value. And then of course we've got V equals IR as well. So this question's asked you to find the currents, I1, I2, I3, and they've got this diagram here. So if we just think about the junction where they are, the Kirchhoff's first law, the current law, is that the current into that junction, which is I3, is equal to the currents out, I2 and I1. So we've got an equation already to start with. But we don't know what I1 and I2 are, so we're going to struggle to find I3. So let's use the other law, the voltage law, around a loop. So I'm going to start, my first loop is going to be here, and I chose that one just because it seemed the easiest. If I pick that as a loop, I've only got one voltage source and one component. That just seems the easiest to get me going. I've chosen that direction. I like that direction because it looks like it's going the correct way through a battery, and it also follows the current through a component. You're not always going to get that, but it's just an easy one for me to start with. So I've got to make sure I follow all these sub-rules as I work out my voltage around that loop. So I got a starting point, I pick there. I just like to pick before a battery normally, but you could start anywhere. I'm going along here, I'm going the correct way through a battery because I come out of the positive end, and so that's a positive 8.5. Keep going around till I meet this component, and you'll notice I'm going the same direction as that current. So because I'm going through the same direction as the current through a component, the voltage across that component is negative. Keep going around, I get to the end of the loop, 0. I can also now substitute in for this component of 2.9 ohms, V equals IR, and we know the I going through that is I2, the R, the resistance, is 2.9, so substitute that into my loop equation. So now I've got 8.5 minus I2 times 2.9, rearrange that, and divide both sides by 2.9 to get a value for I. So I get a value of I of 2.93 amps. Cool. So now I've got my original equation, I3 is equal to I2 plus I1, but through loop 1 I've worked out one of the other currents, 2.93 amps. Great, so now if I can work out I1, I can use my current equation to work out everything. So let's pick another loop. I want a loop where I'm going to do a calculation of I1, so I'm picking this loop here. It's not the only one I could have picked, but it's the one I have picked. So let's go through that. So I'm going to start in the same place, go through a battery the correct way, so positive 8.5. Follow around the loop till I get to this battery, and you'll notice that I'm not coming out the positive, I'm going into the positive. So that's the opposite way that current normally flows out of a normal battery by itself. So in that case, we have negative 6 volts. I'm now going through a component, and you'll see there is a current, I1. I'm going the same direction as that current, so that's negative as well. We get around to where we started from, so it must be 0. I can substitute in for my missing voltage that I don't know across that 3.5 ohm resistor with IR, same as I did before, and I is I1 and the resistance is 3.5. Substitute that in the equation. Now I can simplify this because I have positive 8.5 minus 6. I'm going to do that first, and that's 8.5 minus 6 is 2.5. And I can put my negative I times 3.5 on the other side of the equation. Divide both sides by 3.5, and I get I1 is 0.71. So now I have my original current equation, which I haven't used yet. But through loop 1, I worked out that I2 was equal to 2.93. And through loop 2, that I'm calling loop 2, I worked out I1 was 0.71, so I can put them both in the equation to work out I3, which is 3.64 amps. So there you have it. This is a skill, right? It's a skill like learning to play the guitar, or drawing energy bar charts, or solving anything in physics. It's a skill that needs to be practiced, especially when you've got all these sub-laws or sub-rules you've got to follow for the voltage law.